Solve each equation, indicate extraneous solutions by crossing them out. So we have here a radical equation, and we always know that with radical equations, we have a possibility of introducing an extraneous solution if we square both sides of this equation. And we do want to square, even though it might introduce an extraneous solution. We want to square because that cancels this square root out nicely. Okay, but we don't want to square at the very beginning, because if we did that, we got a binomial here, something minus something else, and recall that a binomial squared is equal to a squared minus 2 times a times b plus b squared. And so if this is our a and that's our b, we're going to have a times b that shows up when we square this. And so we'll have a square root of 2m plus 4 times the square root of m plus 3. That's something I don't want to deal with. So why don't we avoid that by making sure that we don't square at least this particular binomial. I'll go ahead and add square root of m plus 3 to both sides, leaving me on the left with just square root of 2m plus 4, and on the right we'll have 1 plus square root of m plus 3. And now I'm going to go ahead and square both sides. On the right we still have a binomial, but this time our binomial at least only has one square root in it. So this cross product term, this 2 times a times b, isn't going to be that bad. Now we have a plus, so let's change this to the other form of that equation. There we go. So let's multiply this out and see what we get. Square root and the square cancel, so we're left with a 2m plus 4 on the left. On the right, we have our binomial squared, so we get 1 squared plus 2 times 1 times square root of m plus 3 plus the square root of m plus 3 squared, so the square root and the square cancel, and we're left with just an m plus 3. So we have progress. We still have a square root, but we only have one of them. We started with 2 square roots, now we have one of them. That's progress, so we're happy with this. We'd like to get rid of this other square root, of course, so we're going to want to go ahead and square both sides again, but I don't want to square right away, because if I squared right away, I'm in an even worse spot than before, because squaring this, I have 1, 2, 3, 4 terms. If I square out a polynomial with 4 terms in it, I'm going to have lots of cross product-y type things, so I'm going to have lots of square roots of m plus 3 that show up. So before squaring both sides, I'd like to isolate this thing by itself. So I'm going to subtract 1 from both sides, I'm going to subtract m from both sides, and I'm going to subtract 3 from both sides, so that on the right I'm just going to be left with square root of 2 times m plus 3. On the left, let's see what we have. If I subtract m from 2m, I'm left with an m. If I subtract 3 from 4, I'm left with 1. If I subtract another 1, I'm left with 0. So we have m equals 2 times square root of m plus 3. Now it's a great time to go ahead and square. So let's do that. I'll square both sides. Squaring works nicely with products, so the squaring on the right-hand side doesn't introduce cross-product terms like it would if we had addition or subtraction. Instead, we just going to have a 2 squared, so 4, and a square root of m plus 3 squared, so m plus 3. Now be careful at this spot. I purposely wrote this a little bit wrong. It looks like 4 times m plus 3, but we want to multiply this whole 2 squared by this whole square root of m plus 3 squared. So I need to put in some parentheses there. And so this is really 4 times m plus 4 times 3. So 4m plus 12 if we distribute that 4. On the left, we just have an m squared. All right. So here's an equation for us to solve. M squared equals 4m plus 12. Of course, we know how to solve polynomial equations like that. We just go ahead, get everything on one side of the equation, so it's equal to 0, and then we try and factor. So let's take m squared, subtract 4m from both sides, subtract 12 from both sides. That now equals 0. Let's factor what we have on the left here. Factors of negative 12 that sum up to negative 4, of course, are negative 6 and positive 2. So we know that our two solutions are m equals 6 or m equals negative 2. Now we have to check whether or not those are extraneous, so we'll do that real quick because I'm about to run out of time. But if I plug in a 6, I get 12 plus 4, 16. Square root of 16 is 4. And if I plug in a 6 here, I get 6 plus 3, 9. Square root of 9 is 3. 4 minus 3 is indeed 1, so m equals 6 works. Negative 2, I plug that in. I get a negative 4 plus 4, that's a 0. I get a negative 2 plus 3, that's a 1. Square root of 1 is 1, so it's a negative 1. So it looks like m equals negative 2 does not work. That one's extraneous.